Okay, this is 6.6 Digging It. Module 6 totally shifts gears here. And instead of talking about degree measurement that we've been doing in the previous 5 lessons, now we're getting into radians, which is a first for this module, but not a first for you guys, because radians is something that we covered with unit circle in Apex. So some of this is going to start looking familiar. Not all. If you've tried this task, you'll know that there's some new stuff in there too. But some of it is going to be a bit of review, which is nice. 6-6 Digging It. Alice, Javier, and Veronica are responsible for preparing a recently discovered archaeological site. The people who used to inhabit this site built their city around a tower. The first job of the planning team is to mark the site using stakes so they could keep track of where each discovered item was located. Part 1. Alice suggests that the team place stakes in a circle around the tower. Place stakes in a circle around the tower, with the distance between the markers on each circle being equal to the radius of the circle. Javier likes this idea, but says that using this strategy, the number of markers needed would depend on how far away the circle is from the center of the tower. Do you agree or disagree with Javier's statement? So Alice's idea is we're going to take the radius, let's just say it's 1 here, and that's going to be the distance between each stake. So here's like the first stake, here's the second stake, and since the radius is 1, that distance is 1. If the radius was 11, that distance is 11. Okay, and Javier says, well, okay, first of all, how many can we get around there? How many 11s can we get around the circle? And would that be the same amount as a bigger radius, like 22 or something? So you may write down your thoughts on that, and of course we're going to answer it in 2. 2. Show where the stakes would be located using Alice's method. If one set of markers were to be placed on a circle 12 meters from the center, and a second set 18 from the center. Before I start talking about 12, 18, and 18, let's go back to the 1. And let's just think about, if the radius is 1, how many 1s could I get around the circle? Well, what would the circumference be? The circumference would be 2 pi r. The circumference would be 2 times pi times 1, which is 6.28. So this tells me that I could get a little over 6 1s around the circle. Okay? Now let's think about it if it's 12. All right? If that's 12, what now is my circumference? Well, it would be 2 times pi times 12, which I think is 75.36. But let me just confirm that. So 2 times pi times 12 is 75.36. So that's the circumference, right? And the radius is 12. So if I go 75.36, which is the circumference around the whole circle, and I divide it by the radius, that tells me how many radii I get across the circle. And guess what I get when I do that problem? I get 6.28. That tells me I can get 6.28 12ths around the circle. So let's just kind of mark in where that would be. So it's going to be a 6 and a little bit. So you could go like 1, 2, 3, 4, 5, let's see, 1, 2, 3, 4, 5, 6. Well, this looks more like 7. So mine might be just a little too close together. So go ahead and mess with the drawing a little bit on your own and do the best you can. So I'm gonna make mine a little wider. Okay, so I'm gonna go like there. And again, it doesn't have to be perfect. The main idea for this, guys, is that you know that there's a little over 6. 1, 2, 3, 4, 5. That's pretty good. Okay, so this would be like 12, 12, 12, 12, 12, and 12. And then I got this little piece over here. Okay, so what is that little piece? That's the 0.28, but it's not 0.28. Okay, it's 0.28 of the radius. So if I go over here and I go 12 times 0.28, what am I going to get? I'm going to get 3.36. And that means this distance would be 3.36. And guess what I get if I go 12 plus 12 plus 12 plus 12 plus 12 plus 12 plus 3.36? I get the circumference that we got when we went 2 pi r. So now let's think about it if it was 18, okay? So I'm going to add in my drawing for the 18. So here's my radius here, if that was 18. So if that's 18, it would kind of look the same, right? There would be here, here. So what we're getting at here is it doesn't matter the size of the radius. It's always going to be 6.28 around. And this would be 18, and of course the radius is 18, 18, 18, 18, 18, 18, and then 0.28. So it'd be 0.28 times 18, and 0.28 times 18 is 5.04. So then this would be 5.04. And if you were to add all those together, you would get the circumference of the circle. Okay, so no, we don't disagree with Javier's statement. The size of the radius does not matter. Give me just a second. I gotta turn the baby monitor off here, and it's on the other side of the room. Okay. All right, so let's take that now on to problem number 3. Okay, or no, I'm sorry, to part 2. All right, so part 2, now we have a grid and we have a set of instructions. All right, so this kind of switches gears here. So totally different part. Let's read it. Number 3, after looking at the model, Veronica says they got to have more stakes if they intend to be specific with the location of the artifacts. Since most archaeological sites use a grid to mark off sections, Veronica suggests evenly spacing 12 stakes around each circle and using coordinate grid to label the location of the stakes. The central tower is located at the origin of and the first of each set of 12 stakes for the inner circle, and the outer circle is placed at 12,0 and 18,0 respectively. Alice wants to make sure that they record the distance around the circle to each new stake from the initial stakes. Your job is to determine the x and the y coordinates for each of the remaining stakes on the circle, as well as the arc length from the points 12,0 and 18,0, depending on which circle the stake is located. Keep track of the method you use to then find the values. Okay, so this time they're just telling you exactly how many stakes there are, okay? And there's going to be 12 evenly spaced stakes. Let's take a moment and just focus on the inner circle. So we're going to focus on this one in here first, okay? So 12 stakes, and it makes an entire circle. All right, so, and we know that the radius is what? What's the radius? The radius of that little circle is 12. And that's enough information to solve this whole thing. So the question is, when I come out here to my first stake, what is this degree measure here? Well, if the stakes are even and there are 12 of them, each angle would be what? This tells me that each angle would be 30 degrees. Okay, so I know that this is 30. And what's the other piece of information that I know? The radius. The radius from here to here is 12. Okay, so I have a radius of 12, radius of 12. Okay, and what do they want? Remember, we got to record to determine the x and the y coordinates for each stake. So I need the xy coordinate of that. So I'm, of course, going to make a right triangle. And this is probably looking familiar to some of you guys. So if I needed the x and the y coordinate of that red point, and I'm just guessing that it's there right now as I draw this, but I know 30 and then I know the 12. So what is the 12? The 12, this forms a right triangle, of course. It's probably coming back to you, I hope. This makes a right triangle where I know the hypotenuse, but I am in need of this x coordinate here, okay? Now, there's a lot of different ways to do that. We could use trigonometry, but if you notice, we also have a 30, 60, 90 triangle. And do you remember the relationship between the small leg and the hypotenuse of a 30, 60, 90 triangle? It's half. So what's half of 12? Well, that tells me that this distance, that x, is going to be equal to 6. And now the only question is, oh no, I'm sorry, y is going to be equal to 6 because that is that's a vertical movement up, right? So I know that this is going to be equal to 6. Now the question is, how far over did we come? Like, what's this x distance over? Well, we could use properties of a 30, 60, 90, or we could use trigonometry. Now, if I were to use trigonometry, I could use tangent. I would go the tangent of 30 is going to be equal to the opposite, which we know now as 6, over the adjacent, which is a. And then we can cross multiply, and we get 6 is equal to tan 30a. And then we would divide both sides by tan 30. And we would go 6 divided by tan 30. So I have to get my calculator out now here. And I'm going to go 6 divided by tan 30. So 6 divided by tan 30. And that gives me 10.39. Okay? Let me see if I can get both of these on the screen at the same time. Might be getting too fancy here, but 10.39. Now, what's another way I could have done this? Don't worry, each one is not going to take this long, but I could use properties of a 30, 60, 90, and I know that the long leg of a 30, 60, 90 is the short leg times the square root of 3. So 6 times the square root of 3. So if I go back to my calculator now, what is, you could probably guess, 6 times the square root of 3? 10.39. Okay, so this coordinate here, that very first one, I did all this work here, but that first one is going to be 10.39 over and 6 up. So let me mark that here. It's a little over 10 over and 6 up. So that's going to be right there. And that is my first stake right there. So stake 1 is going to be 10.39 over. So I think to organize this, what I'm going to do is over here, I'm just going to write, okay, stake 1. And then I'll go stake 2. And then we'll get the coordinates of stake 2. All right, so for stake 2, think about this a second. I have to close the door. Okay, so stake 2, it's going to make a new kind of triangle. Okay, so we decided that each one, the degree was 30 because there's 12 of them. So that means this next one that's coming up here is going to be another 30 for a total of what? A total of 60 degrees. So just so we can see this, I'll do it in another color. But this is going to come up like this, where that's 12. And then this is going to come down somewhere in here. And now I know that this whole angle is going to be 60. So now I have a new triangle that, again, is a 30, 60, 90. Maybe I'll erase that red one because it's getting a little bit jumbled in there. But what's important is that you understand that this angle is now 60 for stake number 2. So the hypotenuse is always 12. So what's the short leg? The short leg, now this is 6, right? And this is 6 times the square root of 3. These numbers are starting to look familiar. Okay, so stake 2 is 6 over and 10.39 up. Okay, all right, so that's going to go right there. And then you had your other one, and then stake 3. All right, so far we have Stake 1 was 10.39 and 6 up. Stake 2 was 6 over and 10.39 up. So our next stake, remember each one's 30, so it's like 30, 30, and 30. It's straight up at 90, right? It's right up there. So that is 0 over and 12 up. Okay, now we got to start talking about stake 4. So for stake 4, it's coming out like this, and we have another 30-degree angle added with this 90. Okay, so what's going to happen is another triangle would be formed here, right? And if this is 30, what's this? This is 60. And it mirrors, right? It mirrors the triangle that we had over here in quadrant 1. So the numbers are essentially the same, okay? So what was it over here? Remember how this was 6? And then this was 6 times the square root of 3. But now to get over to this coordinate, we're not going 6 to the right. What are we doing? We're going 6 to the left and 10.39 up. Stake 5. So here's stake 5. And of course, it's going to make another triangle. Maybe think for stake 5, what do you think this angle is? Well, this was 90. And then this was 30 and 30. So that whole thing is 30 plus 30 plus 90. What's 30 plus 30? That's 150. And that would leave 30 more degrees for this, which makes our right triangle here that we've seen before. And now it's mirroring the same as this one that we had over here. And what was that? Well, that was stake 1. But this time we're going 10.39 to the left, and we're going 6 up. So you can see how these numbers, they really start to have a lot in common. So for stake 6, way over there, it's going to be 12 to the left and 0 up or down. Now we're halfway done, okay? So we're going to drop down. Let me erase some of this. We're going to drop down to here, and we know that this is going to be 30 degrees. And then we know this is through here. The radius is always 12. The short leg is 6, and the other one is 6 times the square root of 3. So what is stake 7? Stake 7 is 10.39 to the left and 6 down. All right, so I think that you guys can see what to do now. Do check your answers with the answer key that I think will be on Canvas, but I think that you guys will be able to get it from here. So the next one is just going to be, okay, this is 60. Here it is. This is 12. Short leg 6. This is 6 times the square root of 3. So stake 8 would then be 6 left and 10.39 down. And then you just have to go through and do the remaining stakes. All right. And then you also have to do the ones for the bigger circle, which will also be kind of a challenge on that one. So let's just do, so that this one over here, this is the radius equaling 12. And then you could list like over here, the radius equaling 18. So the first one for 18, remember, they're going to have a lot of numbers in common. Okay. So this time the radius is 18, and this is 90, and this is 30. So for stake 1, what would we then have? Well, my short leg is half, and my long leg is the short leg times the square root of 3. So what does that give me for stake 1 for the other circle? Well, it would be 9 times the square root of 3 over, give me just a moment, please. And that would be 15.59 over, and then 9 up. And then just keep in mind as you're going that that's going to mirror this stake over here, okay? Because these two would come straight across. So what stake number is that? Okay, well, we have stake 1, stake 2 will be somewhere in there, stake 3, stake 4. This would be stake number 5. Let's go ahead real quick and just do stake number 5. Well, it would be left 15.59, and it would be 9 up. So go ahead, and I think that's enough to fill out problem number 3, which is really quite a big problem, and you'll be able to check your answers in the next video.